All right, my name is Patrick, and today we're going to talk about the actual diagram of how the steam heat works inside a residential building. So another video, we went over the basics. We simplified the whole setup by showing you kind of like the theory. However, the theory needs to be put into practice, and the moment it's put into practice, all the elements are necessary. So first, I'm going to go about the actual workings of the steam heat system, and then maybe later in some other video we're going to compare one-to-one so that you can see and understand this more clearly. So here we have a boiler. What boiler is basically a vessel with some water inside, and as the moment you apply some heat to that water, by definition that water turns into steam, because the steam the boiler has some kind of pipe attached to it. So because of that, the steam can be directed via this pipe to enter all the elements of the system. So here the very pipe coming out of the boiler is called header. The purpose of the header is so that to slow down the steam velocity, and also to allow it to kind of cool it off a little bit as the steam is happening. This water level right here, it's kind of quite violently going up and down, and because of that, some kind of what it's called a wet steam can be sent up the header into right here. So it's actually quite amazing when you watch some videos of how much kind of force a surface of the water has when it releases steam. So some of that water goes up the header, and because of that, it touches that first cold pipes, but that later on when they warm up hotter pipes, and with that all the turns and twists, it releases some of its velocity. When steam loses velocity, it also loses some of the wetness to it. It's wetness, of course, we're using the totally wrong terms. And that wetness or condensate returns back via the header that's pitched in this direction. So the rudder goes down, and then this condensate returns back via equalizer into the steam. So equalizer in theory is meant to equalize the pressure between the outlet and inlet. There are some theories that actually doesn't do that much. What the main function of equalizer in a residential steam heat is to allow the condensate to return safely back into the boiler. But for a moment, that's the name of that extra pipe extending out of the header at the end of it. It's called equalizer. Somewhere along from the header, we have another pipe going up, and what it is, it's called riser. By definition, the function of a riser is to allow the steam to go raise up and go farther into our main pipe, which is this one right here. And from this main pipe, we have different different extra pipes that connect our radiator. Here, for the sake of simplicity, we only have one radiator connected to it. We can have a bunch of different radiators, one here, another here. Then at the end of the main pipe, you have a main vent. The function of a main vent is to allow the steam to push the air out of the pipe, and at the same time close. So the main vent closes the moment the steam hits it, and the hits it as in warms it up, or kind of in essence warms it up. So the moment the vent detects there is a steam hitting it, it closes so that no more air can escape via the vent. Of course, the purpose of it is so that you don't waste this precious steam and warming up this basement right here, as opposed to going where it's supposed to. When that happens, the steam finds some other ways of going up the pipes, and then find one pipe right here, and goes up the riser to the one and only radiator that we have in our simplified drawing. So the steam enters our radiator via our main vent that's not present, main valve that's not presented here. It would be normally here that you can open and close, and there's only on and off to the main valve. And then when the steam enters the radiator, of course it heats it up and tries to push out all the air via air vent. And as it's happening, of course, the radiator releases heat, and then the cold radiator or coldish radiator, of course, at least less hotter than the steam, condenses, so the condensate can flow back into the pipe. If you notice, this radiator is actually pitched kind of like in this direction, so that the condensate can via gravity return into our main pipe. And this pipe, if you notice, is pitched in this direction, so that again via gravity the condensate in essence being water can return back to the boiler, and then returns back via this pipe that's actually pitched this way. And then we have something called Hartford Loop, which was basically a preventive measure, so that when if there was like a leak in the system somewhere, so the water doesn't flow out of it. So Hartford Loop is very usually a short pipe that's very close to the boiler, so that the boiler never loses water via some kind of leak along the path, and that means this boiler always has some amount of water in it, so to prevent the firing the boiler when there's no water inside, because otherwise the boiler would heat up tremendously, and then at some point if someone would put some water into superheat the boiler, then it could explode. And that's kind of like a realistic view of how the steam heat system looks like in a residential building. As you can see, you have boiler water somewhere here. If you notice, Hartford Loop is below the boiler water, so it has to be high enough to prevent lots of water loss in case there was a leak somewhere happening here. At the same time, low enough so that when the water level moves up and down, because of the boiling function, that there is no steam entering the Hartford Loop, and that to prevent a water hammer. That's basically it. So in essence, the fundamentals: steam goes here. The pitch of the pipe is very important, so that via gravity the condensate knows which way to flow. The pitch of the main pipe is important. The pitch of the radiator is important, so the water doesn't accumulate in any places, but rather continuously keep on flowing where it's supposed to go to return to the boiler. And that's basically it. Hope it was helpful.